Hi, this is Richard C. I'm a math tutor here at Wyzant. I'm answering a question submitted by a student. Students interested in this function h of x, and it's equal to the absolute value of x squared minus 9 over x squared minus 9. The simple answer regarding the domain of this function, the simple way to do it is just the domain exists only where the denominator is not 0. So if I just set this equation, x squared minus 9, we just want to make sure that's not 0. And then we factor this, x plus 3, x minus 3 can't be 0. So that means x can't be 3, and x can't be negative 3. And if we put this in interval notation, which appears to be what the teacher wants here, it would be negative infinity to 3 negative infinity to negative 3, and then union negative 3 to 3, and then union 3 to positive infinity. And so that's a quick and easy way to do it, but I don't think it's satisfying intellectually. So a better way to think about this is to realize that the numerator is always going to be positive. And so no matter what x is, and no matter what x squared minus 9 is, the absolute value of anything is going to be positive or 0. However, the denominator could be negative. And so you want to ask yourself, where is the denominator negative? X squared minus 9 less than 0. Where is that happening? Well, it's happening when x is between 3 and negative 3. So if the denominator is negative, the entire function is negative. And the denominator is negative between negative 3 and 3. So the graph is really a strange one. So between negative 3 and 3, the answer is negative 1. You see, because this over this has the same magnitude, it's just a question of the sign. And so you have a graph that looks like this with open intervals. The endpoints are open. It's not defined. We just gave the domain here. It's not defined at negative 3, and it's not defined at positive 3. But it's a negative 1 here in this interval, but everywhere else it's a positive 1. Because when the numerator is positive, which it always is, and the denominator is positive, which it is in these intervals, you have a positive 1. So it is kind of a weird question. It's the kind of thing you would maybe come across in a calculus class or maybe an advanced algebra class where you're working on domain and range for unusual functions. This one certainly is an unusual function. If you're in calculus, this also has this function has other useful properties that would illustrate other things that you'd be using in calculus. But for now, we'll just stick with the question as asked. So that's our domain. Sometimes you can get away with expressing the domain like this: x can't be 3, x can't be negative 3, but it looks like the teacher wants the interval notation, and that's all you need. Okay, so that's it for this question. I'll see you again next time. Bye-bye.